So where we left off, we just found that b squared equals 24. So we went and plugged that in. We simplified the 7 squared because again, it's opening on the y-axis, so that number should be bigger. Okay, so we look at it. It's at the origin. This gives us a 7 going this way, so that's good. That's good. We had the foci in there. The only thing we didn't have correctly, and granted we just did a rough little picture to get an idea, and then we want to come clean it up, is we need to find this C distance right here. Once we found, the B distance. Once we found b squared was 24, on your graph paper, just make it pretty much 5. Okay, so we're going to go square root of 24 and negative square root of 24 because that's centered right at the origin. All right. There's one example at the origin. If it opened on the x-axis, it'd be the same thing, except these two guys would be flipped. Now, you're starting to see these again. Okay, so it's all in standard form here. Unlike the parabolas, we have an x squared and we have a y squared, so that tips us off that it needs to be either an ellipse or a hyperbola. We haven't done hyperbolas yet, so it's got to be an ellipse. So what you want to do with this is basically complete the square. Okay, a couple times here. We need to get this into the ellipse form. So grab all your x's, put them together. Okay, leave a space. Grab all your y's now, put those guys together. Take this guy, swing it to the other side. Make sure it ends up as a negative. Now, you can't complete the square if you have an a value here. So we have to factor. Notice I'm leaving the space every time too. So what we just wrote is the exact same thing as the original, we're just modifying it. So now we have an a of 1, that works. So we take half of 8 is 4, we square it as 16. But we didn't just add 16, you really added 4 times 16. So come over here and make sure you get that guy in there. Right? Half of negative 4 is negative 2, squared is positive 4, but we didn't add 4, we really added 9 times 4, so make sure you do it to the other side so everything stays balanced. Now we can factor. So this always factors to half of b squared. This will always factor to half of b quantity squared. Those will cancel and you get a 36. So you're getting closer to your ellipse form here. Now, if you can get here, it's tempting to try and like divide by 4, divide by 4, divide by 4, but that doesn't really get you where you want because our formulas for ellipses always equal 1. So yeah, this will cancel, that's nice. You don't want a 9 over 4, because that doesn't do you any good. 36 over 4 actually works, but it doesn't get you to a 1. So ignore the 4 and the 9, come over here, turn this guy into a 1. Now if you did your completing the square right, these numbers should come out nice and neat. So if you get something like 7 over 36, you probably didn't do it right because our numbers should come out a lot better for us. So we take this guy and we see what happens. 4 goes into 36 9 times. That looks like an ellipse form right there. 9 goes into 36 4 times. So that looks like an ellipse right there. And this now equals 1. So we're in our ellipse form with this guy right here. We take a look at it, and we can say the center is at negative 4, positive 2. We can say a squared equals 9. We can say b squared equals 4. So if we were to draw a rough picture just to get an idea before we go clean it up, the center is over here. The bigger number is underneath the x, so it's going to open up on the x-axis that way. So here's going to be a, here's going to be b, and then c's hidden in there, because remember a really comes up to that guy like that. All right, so let's get a better picture now. There's all the work, everything we just did. Here's where we're at now. -4, 2. Label that center. We know a squared is 9, which means a is a 3. So 1, 2, 3. That's going to be a vertex. So we know it's opening up on the x. 1, 2, 3. That's going to be another vertex right there. So vertexes are our center of -4 plus 3, comma 2, and -4 minus 3, comma 2, which gives us the same values as we did on this picture here. So vertex is -1, 2, and another vertex is -7, 2. Right? We know that b squared, we'll move this up here. We know b squared equals 4, so b equals 2. So from the center, this guy's coming out 2 and down 2. Okay, so you can find your other vertices there. Now the only thing we need is those little c values for the foci. Okay, so right now we can put our picture in like that, okay, but we do want the foci. So if you think about the little triangle that's going to be in here, I'll draw it up here. We know this is going to be B, this has to be A, because it's the same distance from here to here as it is vertex up to that vertex up there. So then this guy needs to be the C. So plug in some values now. We know A is 3. We know B is 2. So 9 equals, we'll call this guy C. C squared plus 4. That means C equals 5. So C equals plus minus square root of 5. So if you want to find your foci, so basically we're going a little bit more than 2. So we'll put dots there, foci and foci. If you want to list these then, it's the center of -4 plus or minus square root of 5, comma 2. Right? If we had to do that on the y-axis, we'd add it and subtract it from the 2. I'm fine with you leaving your answers like this. Okay? So we're going to go -4 minus square root of 5 and then up 2 to get to that guy. -4 plus the square root of 5 and up 2 to get to that guy. Okay, so you want to make sure you give me center, you give me vertices, you give me the foci. Okay, and that's how we're going to do everything here. Notice we didn't have to memorize the goofy Pythagorean theorem one because we just drew a little picture in there. We just pulled this triangle out to there. Okay, so we will keep working with this stuff and bring some questions to class.